Today we have an opportunity to have a lecture by organization Boulouki. I'm just going to give a short introduction of Boulouki. So Boulouki is an interdisciplinary research collaborative whose work is focused on the study of traditional building techniques and materials. In Greek, Boulouki means gaggle, traveling group, a name evoking the traditional traveling companies of stonemasons and craftsmen. Its aim is to trace and document the living carrier of such traditional knowledge, to study and to further disseminate it through workshops and actual building projects which are organized in collaboration with local communities. So today we have Ioana Dutsi, chemical engineer, and Grigoris Koutropoulos, an architect, who will present our work regarding the restoration of traditional water systems and such. So I give you your words, Ioana and Grigoris. Thank you so much for participating and for being a part of this project in this way.
Thanks, Maya. Can you hear us? Can you hear me?
Sorry?
Can you hear me? Is it okay? Okay, thank you. Thank you, Maya, and thank you, Association Tatavaka, for inviting us to participate in this workshop. It is indeed quite useful that these initiatives as jobs projects are taking place. We have to rediscuss and rethink traditional water management and traditional water infrastructure in terms of all the environmental issues that we face. And so we are very happy to participate in this event, and we hope that all the workshop activities are taking place smoothly. And I'm going to share now my screen. So let me know if you all can see the content. Is it okay? Okay. I don't know what to do that. I hope that it is okay.
It is.
It is great. So as Maya said, I'm Ioana Dutsi. I'm a chemical engineer specialized in materials for cultural heritage. And today we're going to present you, along with Grigoris Koutropoulos, some approaches based on our work on the restoration and reuse of traditional water management infrastructure in insular communities of Greece. But before going into the specific case studies that we have on two Aegean islands, we will have a short presentation of what we do, a little more focus on how we approach traditional building techniques and materials. Boulouki, its full title is Itinerant Workshop on Traditional Building Techniques. We are a non-profit organization based in Athens and currently trying to develop our base in Epirus, northwestern Greece. The team was founded in 2018, and the name of the team, the title Boulouki, as Maya said, evokes this tradition of itinerant masons, these gadgets that were traveling around, masons that would work in as a group in Epirus, in the Balkans, in Mediterranean, but also worldwide. And this is a historical picture of such a Boulouki from the early 20th century. So today we are developing this new interdisciplinary team of architects, engineers, but also cultural managers and social scientists and archaeologists, and many collaborators that derive from different backgrounds, like environmental or geological background. But also in our team, in the core of our team, there are craft people and people that we work together. They instruct the participants of our educational activities, and we work together in order to reclaim this knowledge over traditional building practices. What we want to achieve in the long term is to reshape the building culture in Greece, but also in Balkans and worldwide, and to foster the use of this knowledge on traditional building practices and this knowledge on raw materials management, and how this knowledge is very important to be integrated into contemporary building practices. We work with local communities, and we want to document, to identify, to document, and to further disseminate the knowledge that exists inside local communities on techniques, on materials, on landscape management. And we try to do that through diverse educational activities and through actual construction projects. We support the sustainable use of natural resources, the community engagement and participation, as we said. We try to develop further the access of the majority of people to this knowledge on traditional buildings. And we work in terms of interdisciplinarity, in exchange, in mutual work, in mutual respect between the different professionals that we cooperate. And we think that, especially in Greece, but also in other countries, and this is something that we have discussed a lot with Maya and Dragodid and other teams from the Balkans, there is a gap between the research and education that is taking place over historical and vernacular architecture and the practice itself, either in terms of restoration of historical buildings, but also in contemporary buildings. So this is why we try to revitalize this knowledge and to approach the carriers of this knowledge, the older practitioners that are decreasing, unfortunately, in numbers as years pass. And why do we think that traditional building is important and these traditional building cultures are important to be safeguarded? Because they promote the use of local materials, and this is something very important in terms of integrating approaches of zero transport and low environmental impact of construction practices. It promotes in this way the sustainable use of natural resources. We believe that vernacular architecture and historical building practices are intertwined with the protection of the natural environment. We think that it is a way to evoke the interest in the collective care of common resources, and this further enhances the community building and the preservation of local cultural heritage. And as a whole, this can contribute significantly to the prosperity of local communities, even in terms of economic growth. There are mainly 4 pillars on which we base our work: research, education, practice, and public dialogue, dissemination. In terms of research, we're of course discussing about architectural research, how the historical structures on their own can teach us significant lessons. So we have to study them, we have to document them, but also they can, we are not discussing only about the restoration of historical practices, we are discussing about how traditional building techniques can be integrated into modern practice, modern architectural practice. We are conducting a lot of laboratory analysis on historical building materials and a lot of scientific research for reclaiming this knowledge, because we have to decode, let's say, the historical knowledge that is not well documented, and because we also have to test and to evaluate the new materials that we're using in restoration projects and new constructions. So we are developing synergies and collaborations with national and international research institutions and laboratories. And we also integrate an ethnographic approach in our research, meaning that we conduct field research to connect with the last carriers of this knowledge, the elder nations that can transmit us this knowledge and these memories of working with stone and with lime and with local materials before the arrival of Portland cement. But also documenting, it is important to document the knowledge that exists inside the communities as a whole. I mean, apart from the technical, the people that were technically involved, we have witnessed that Historically, the whole community knew about these practices, knew a lot about how to sustainably use the local materials. Regarding the pillar of the education, we have different formats, educational formats. Mostly two of them are the apprenticeships, meaning intensive technical training programs that are addressed mostly to professional craftspeople. And they combine practical training in actual restoration projects or other construction works that are guided by our collaborators, our craftspeople collaborators. Also, there are hands-on workshops that are taking place that we organize. That might be from 3 to 12 days, complete programs that include hands-on training, but also lectures and guided tours and seminars and different things around traditional building techniques, around the cultural and natural heritage of each region where we work. In terms of practice, we try to conduct different kinds of works, from construction and conservation works on historical buildings. We have been mostly involved with pathways, cobblestones, calderini, as they are called in Greek, but also in many Balkan languages. But also we have conducted several works that have to do with traditional infrastructure and how it can be a solution that can tackle environmental challenges. And these are the two case studies that we're going to discuss later on. And as I said, we also conduct new architectural projects that are based on traditional building techniques. And the fourth pillar, the dialogue, we are trying to influence and reform the academic and the institutional framework in order for the traditional practices to be applied in the modern construction. And we are doing a lot of dissemination activities, from lectures to symposia and roundtable discussions and exhibitions, publications to disseminate accumulated knowledge. Again, this is a pictogram of several numbers for our work. We have conducted more than 7 construction projects based on historical building techniques, 3 professional apprenticeships, where more than 20 nations participated as tutors, and also have trained 16 apprentices. Some of them are still professionally involved with restoration projects. We have conducted 13 actually hands-on workshops. We just finished our last one. And you can see some more numbers regarding our work. And as a whole, we can say that our approach is shaped by 4 axes: participation, hands-on approach, interdisciplinarity, and diversity of the stakeholders involved and addressed too. There are 2 areas in Greece where we have mostly worked and where our interest is mostly placed: Epirus in northwestern Greece, a mountainous region, and Cyclades in southern Greece. The most well-known islands of Greece. And I'm going to continue now by presenting the first case study regarding the traditional water management infrastructure that we have worked on. This is the project Under the Landscape. It was conducted in the region of Santorini, or else known as Thera, and Thracia. Actually, it's an archipelago, meaning an assemblage of group violence. And this project was a hands-on investigation on the local material knowledge systems and the local building practices, but also the cultural values that underlie the specific architecture of the area, the unique architecture of the area, and the landscape of this place. And it was also a trial to foster the need for safeguarding this architectural legacy and these local practices in view of the commodification of the area and the vast touristic masses that every year subsume the islands. Santorini is very well known, I think, one of the most well-known areas in Greece. These are two geological maps depicting the unique geology of the area. It is one of the most, the area is one of the most active volcanic centers in the South Aegean volcanic arc, as it is called. Actually, this is Santorini, I see the big one, and this is Thirassia, the small twin island that was once connected to Santorini, but it became a separate island after the well-known Minon eruption or Thiran eruption, an eruption that took place in the 17th century BC, and it is one of the most intense volcanic eruptions that are recorded historically worldwide. This yellowish color that covers almost the most part of Thira and almost the whole surface of Thirassia is the deposit, the main deposit that was created by the Thiran eruption, Thiraner, that we're going to discuss more as the presentation follows. And again, this is a more detailed geological map of Thirassia, and this blue layer is Thiran tephra, this layer deposited with the Thiran eruption. This is how Thiran tephra looks. And it is quite important because it is what we historically know in the history of architecture as a pozzolan, a natural pozzolan, meaning a volcanic product, an aluminum silicate product, which when it is combined with lime putty gives very good mortars, very good building materials. And it is actually one cave settlement that we were involved during this project, which is in this area of the island of Thirassia, Agrilia, and this is most probably the first depiction of Agrilia in a map from the mid-19th century. Again, a map, but this time depicting the hydrographic network of the island. We have several streams, quite a number of streams, but they are mostly of seasonal flow, and they create like autonomous small-scale hydrological basins. The annual rainfall in the island is very low because the climate in the area is characterized as semi-arid, actually, and it is quite. It's one of the two places in Greece that have this type of climate. And we also have a very high average annual temperature, high sunshine, high wind speed, and all these factors favor the evaporation, the surface runoff of the water. And we also have a geomorphology that is not very suitable to accommodate extensive aquifers. So all these agents contribute to having small groundwater reserves. This is the pathway that we were involved with during our restoration project. Okay, this is in the satellite image you can see here is the settlement of Agrilia, and the pathway continues all the way up to the other settlement, the central settlement. And you can also see that the settlement is actually built inside a ravine. And you can also see the terrace landscape, but this is a very characteristic view of the morphology of the whole surface of the island. And this is a picture of how the settlement looks. So we are here in the entrance of the settlement. This is the main pathway as depicted before with the red line that goes all the way up to the central settlement of the island. And the settlement of Agrilia, where we walk, is mostly unfolded in this area and here, inside the two ravines. And these are actually the layers of Tiran tephra that we explained before. And you can see the cave dwellings that are carved inside the terrain, along with the terraces, how they shape the landscape, the terraces used for cultivation. Again, some photos, more specific photos from the main pathway of Agrilia. One of the first things, actually the first thing that we did before getting into the restoration works of a big part of this pathway was to clean up all the way up to the central settlement, because it was totally closed from the last vegetation. It was not accessible due to the last vegetation. And here is a view of the central pathway made from volcanic stone, along with some walls on the sides, and the main church of the settlement. The settlement is abandoned, is quite abandoned after the 70s, because most of the people moved from Thirassia to come to Attica to work here. And actually, I will leave for a minute from this presentation to just present you this. Sorry, it didn't work before, but this is actually how, I don't know if you can see, I hope you can see. Okay, this is actually the main pathway of Agrilia.
We see the same PDF that you were showing us before.
Okay. So if you can see
You
can see what you can see, sorry. Can you see the GIF that I'm showing now?
Yes, now we see also the PDF, the same. You want to show us something else? The animation?
Yes, I'm showing an animation. Isn't, I don't know why.
You can exit, maybe you can exit share screen and then share screen again.
Okay, I will do that. Sorry for the inconvenience. Okay. Share screen. Now, are you seeing this animation?
Yes, yes, we see.
So here you can see how here you can see how the pathway works, functions when it rains. Okay. What I didn't say before is that the main pathway of Agrilia and the Agrilia settlement itself is built inside the ravine and above one of the water streams that we saw before, one of the underground streams that we saw before. When it rains, the pathway diverts the rainwater inside this kind of infrastructure systems that are embedded in its roots. Okay, and they store and collect the water. And this was one of the core axes on which our restoration work was based for this work, for this project. And I'm sorry again, I will stop sharing and share again. Can you see my screen now? I'm in my PowerPoint, my PDF.
Yes, yes, yes.
Okay, so this is something to keep in mind for explaining more on the restoration project. And also this is a depiction of how these cave dwellings look like, how these houses and storages and different infrastructures are carved sideways and downwards into the tephra deposit, the mineral tephra deposit. One part of the project was studying this architectural paradigm, which is quite unique, not only for Greece, but in the Mediterranean scale at least. There are few of such examples left, especially in the area, because of this whole touristic growth of Santorini. They are mostly turned into touristic accommodation places, and they have not kept their characteristics. In Thirassia, you could see how these dwellings look like. And actually, Tetra was a very important mineral, also mined and extracted and exported in many areas worldwide to be used in various projects of mostly hydraulic projects, meaning, for example, in the Suez Canal or in other hydraulic projects around Europe and the Mediterranean. And these are the historical quarries. And there is a large archive in Greece that we found from the Technical Center of Greece about how you could use this material along with airline to produce very long-lasting mortars and concrete, and different samples were collected from historical structures of the areas in order to document this knowledge about this hydraulic mortars, as we call them. These materials not only harden underwater, but they are also water resistant. So we can see here an aspect of materiality depicting these wise ways of saving water. And these are several samples that we collected, mortars or local concrete that were used in vaulted structures, and we tested them in the material, in the laboratory. We tested their material properties. We analyzed Tetra to see what are the characteristics that should be defined as suitable for its use in mortars and in order to reuse the local material. And these are all aspects of one handbook that we published on the use of traditional building techniques of Thirassia and Thira. And this is the material in different granulometries as we analyzed it, and we used it to test new specimens, how we could develop new building materials based on the historical recipes that we also documented through interviews with the local craft people. Again, several scientific results from that, and all these are published in Greek. We also tested them in terms of modern performance, how they could withstand the aggressive salt spraying that is taking place in the islands, how they behave in terms of thermal conductivity. They can be used in terms of insulation and all these aspects that we have to take into consideration in order to reuse these materials in modern practice. And apart from documenting and analyzing and understanding the material knowledge of mortars, we were involved with documenting and analyzing the specific characteristics of the dry stone cobblestone pathway that we restored. This is one of the systems that we also restored on the route of the pathway. And there are several architectural details that are related with the water management, meaning the use of very large stones that divert water towards the surface of collection before entering the water cistern, the inclinations in different parts of the pathway. And this is like the whole part that was restored by our team, mostly almost 80 meters in length. And this is the interior of a system after it has been cleaned, and after all the debris and vegetation was removed, and how we document the shape and the architectural details that you see here in the sections. Again, some documentation on the systems and how they look like and how they the stones, how the external surfaces collect and divert the water inside. And this is an axonometric sketch of the whole cobblestone and the pathway, as we saw before, also in the animated piece. We used local materials both for the cobblestone and for the systems, the restoration of the systems. We used local materials, apart from the fir and earth that we mentioned before, and it was collected in situ, in Avila. We collected stones from this old quarry, lava stones and other volcanic stones. And one of the issues that we had to face was that there was a new system of sewage and water pipeline that had to be installed prior to the restoration of the cobblestone, and we did that along with the local authorities. And this is a view of the cobblestone, how it used to be, and the system here. It was for us an opportunity to really study the local technique of plakoto, as it's called, a more specific dry stone technique. We also restored, apart from the pathway, we also restored the neighboring wall, a retaining wall, double leveled wall. This wall that was fallen. This is after the restoration, the result after the restoration. And this is how we approach the restoration of the systems. What was important was to reapply the traditional mortars technique, this technique based on the use of fir and earth and lime, as I said before, which had multiple layers. And here you can see the masons that we work with, local people from the area, that they weren't themselves aware of the technique, but we had tested them in the laboratory and we experimented with them, and we applied them to restore the cistern. And here is the situation before, for example, external surface and internal. Okay. And here are the several layers of this technique that were applied in order to waterproof the system, in order to maximize its ability to collect and store the water. And the external surface was restored using a local concrete technique, again with fir and earth and lime, but also with with larger pumice aggregates. Okay, and here is how it is applied. And this is how the system is restored, the ultimate result. And the ultimate result from its interior. And to sum up, this work was done collectively, and it was done through a professional apprenticeship where 3 tutors and 4 apprentices participated. Most of them were people from the area, either Pirasia or Santorini, but also through a 2 weeks hands-on workshop where 20 participants from Greece and abroad participated. And we had some open days for the local community where residents of Pirasia and Santorini were able to join the works and to see how a system looks like and how it used to work and works, how it is restored. The same for the pathway. And that's it from me. And then we now give a speech to Grigori. Continue.
Okay, hello everyone. Thanks for the invitation, Maya and Tatavaka. I'm moving now, sharing my screen. and presenting the second case study about water management systems from Greece, a traditional practice with micro dams. Here it's the first icon is a picture from an English traveler from 19th century. Shows this practice that creates small throats for irrigation and small reservoirs for water for biodiversity during the summer months, and somehow to enrich the aquifer of this region. And here is the present situation, because this was a fantastic story for the English traveler from 19th century, because as you can see, it could be a nature-based solution and practice that could be real from ancient times. This is the real photo from the construction of one of the microdams that we did last summer in Paros, and Maya was joining us during this workshop last year. So what are these nature-based solutions? Systems that are promoted to face the climate change in this kind of sensitive ecosystems. Here are the two definitions from International Union for Conservation of Nature. They are the actions to protect, sustainable, manage, and restore natural and modified ecosystems that address societal challenge effectively and adaptively, simultaneously benefiting people and nature. And one more definition from United Nations Environment Assembly is that also here nature-based solutions are actions to protect, conserve, restore, sustainable use and manage natural and modified terrestrial freshwater, coastal and marine ecosystem, which address social, economic and environmental challenges effectively and adaptively, while simultaneously providing human well-being, ecosystem services and resilience and biodiversity benefits. But how old is this practice with microdams? Here you can see an example that archaeologists found in prehistoric Crete in Zakros, a system of microdams and retaining walls that was used to cover the needs for water for a small agricultural area with terraces. And on your right, there is the dry stone technique of this kind of constructions, a small-scale dam. And now there are more examples of microdams constructions all over Greece and abroad with different techniques and different materials. And it's worth mentioning the example of Aos River in Epirus, and also in Evia, where the Forest Service construct these dams to prevent the soil, the ground erosion after the big fires that disaster the forest 2 years ago. And also there are some examples from Slovenia with this kind of timber construction in small streams in the forest of Slovenia. Now we're moving, sorry for that, on another island in Greece, in Apeiranthos, in Naxos, in Cyclades, where between 1992 and 1994, Manolis Glesos, a Greek politician and the president of Apeiranthos, had this initiative to construct this big number of microdams in Apeiranthos watershed to enrich the aquifer of this area and also raise awareness about water scarcity in Naxos Island and also in Cyclades, in this kind of fragile ecosystems all around South Greece. And this was the first pilot program in 30 years ago in Greece. And after that, let's find out the values of for the society and the environment of this kind of traditional practices. First of all, as for the environment, this kind of construction are built with local materials. The stone is found in this place, and it's a natural and reusable material. Also, the footprint of this construction is very low. It's used to enhance the, as we said, the biodiversity, because they keep water in these reservoirs during the hot, dry months, summer period. Also, they enrich the aquifer, and they inhibit the soil erosion, and also they prevent the floods and this kind of natural disasters. Also, they create new local working positions that cannot be mechanized. They're traditional kind of crafts, and in this way they strengthen the social cohesion, and also there's a recognition of this kind of specialization as a cultural and living heritage of the area of the people. Also, these practices and this construction preserve the traditional landscape, and they identify of the society that is reflected on the landscape. They shape the unique landscape as a barrier to landscape standardization, and they help the water and also the land management to the community. And last but not least, as for the economy, it's an environmental friendly economy of this dry stone technique. It's a green infrastructure, and it's ecological building. There's this kind of cooperation, ecosystem cooperation between all the craftspeople, the researchers, some educational institution, the local community, and also the authorities. And also we have these are the principle of the circular economy, and just mention the revitalization of this productive structure, the terraces and these hydraulic infrastructures. Now let's move in Kythera, another Greek island in the Aegean, where the Medina institution, the Mediterranean Institution for Nature and Anthropos, started a revival of this practice in 4 years ago, where it was a traditional practice that the Kytherians called thesis, this kind of construction, the microdams that were built across the flow of the stream called Karavas, and it was for a better utilization of water and for irrigation. So these low dams make level alongside the riverbed, so the speed of the water flow is reduced, creating small roads that make the water available for irrigation and also for other uses. It's worth mentioning that this construction, the microdams, were built in combination with other traditional infrastructures, such as dry stone walls, water mills, canals, terraces, etc. And all these stone-built complexes contribute to integrated water management in total. So in this first attempt, the preparation that was done, the first step was the detection and the recording of the place, the location of the microdams. Also, it was necessary a technical report that it has to be licensed from the authorities. And here are some small technical aspects of this construction. The average length, it's a very small scale construction, 1.5 meters. The height is less than half of a meter. And the filling surface is approximately 100 square meters. And the filling volume less than 50 cubic meters. Now let's move to Paros, where during last June we implemented the next project about microdams in Kavouropotamos, which means the Crab River. It's a periodic flow stream, and its watershed is 5.9 kilometers in south east of Paros. And also here the first step was the position of these microdams. It's very crucial to find the best place to construct the microdams. Also, the team that did this field research found some traditional dams there, so we have to restore them and renovate them. But also they made the technical survey for 33 new microdam constructions in length of 1.33 kilometers alongside this Kavouropotamos stream. And in this project, for the first time, we introduced the monitoring of biotic and abiotic parameters of this intervention in the stream. So we have to document the type of the habitats, the reptiles and amphibians, the terrestrial and aquatic invertebrates, and also for the abiotic parameters that we have to check before and after the construction of the microdams. It was the water level change in a nearby borehole and the conductivity of the water in this area. So the colleagues from the Institution of Speleologic Research did this monitoring before and after the intervention. They had 5 locations that were selected for sampling as sampling stations, and they did a qualitative sampling of terrestrial invertebrates. Was carried out at each station, and 3 propylene glycol interferences traps were placed per station with an average retention time of 1.5 months. There were 3 sampling changes before construction of the microdams and 3 after the construction. And 2 sound recorders were placed a total of 4 times on a similar date to the other samplings. Also a survey of reptile and amphibian species and the status of population and habitats was carried out at these 5 stations. And 7 reptile species and 1 amphibian species were found. And we hope that all reptile and amphibian species are expected to benefit from the project. And to be honest, the statistics and the results after the interventions are not so encouraging because it needs a lot of time to better the condition for biodiversity and also for the aquifer. So we're going on with monitoring for the next year to I'm hoping changing the numbers of biotic parameters. And as for the building aspects, the technique that we used, it's like a small arch that is constructed on the ground, as you can see in the drone photo and also in this small sketch. It's dry stone construction with all the material from the place. But the crucial thing is to find 2 stable rocks in these 2 sides of the stream and place the foundation and the upper construction of this, let's say, small bridge that is planted on the ground. And also it's an arch construction because in this kind of construction the water in flood is going and the pressure goes on the 2 rocks on the 2 sides, and in this way we have very stable and durable construction. Here you can see that this custom construction of the 33 microdams that are all different with each other because they're adapted in the exact place that they are constructed with the local material that in any case it's different from the other place. Just show the diverse of this kind of construction alongside this this Kavropotamo stream. And in the last year project in Paros, have to mention the participatory approach, the education and raising awareness during this process. We trained local craftsmen tutors during this construction process. Two of our nations of craftsmen were born and raised in Kavropotamos place, and we found them and we engaged them in the educational, the construction process. And also we have the involvement of volunteers, like 15 participants. Maya was one of them, and local community was it was open for the locals to come and visit us and participate in the construction process. And also it was created a short documentary from a child from the secondary school of Paros. And finally, we organized an open event with public dialogue on water resource management issues in the town of Paros. So we're all invited, all the local community and also the stakeholders of the region, discussing the problems of water scarcity and also revitalizing these practices for water management from the past. And next step of this initiative in Greece is the case study of EOS, also in Cyclades. It's a med-research project with the Medina here is and WWF, the group leaders. We are the subcontractors of pertaining the technical aspects of the project and the construction of 50 microdams in Mavroudi stream. And in this project, we have a collaboration with the Agricultural University of Athens that did a great research in depicting the hydrological parameters that affect the position of the microdams and their impact in the aquifer. And here you can see the site of the Pertesi watershed. And one example during the field research of a place that called microdam that exists in this area, and the locals called Souvales. It's a place for gathering and collecting the water for the summer months. And also here you can see the technical study that shows the location of these 50 microdams that are going to be constructed in 2024, next autumn. And you are all invited to participate in the construction process and maybe in the workshop that we're going to organize the next September or October. And last but not least, just see a small video in this area that shows the big amount of water that is needed in the sea, and with these kind of practices and techniques, we can keep it and reinforce and enrich the aquifer of this island and this fragile ecosystem. And as a good practice for water management in this kind of difficult dry situation in South Greece. Thank you very much.
Thank you very much for your presentation. You gave us a valuable insight in the types of restoration of traditional architecture and the ways in which we can also be inspired to do it in our own local communities. Does anybody have a question from the audience? Questions? Comments?
Thank you for the invitation.
From the audience, they're thanking for the invitation for the workshop. And I have one question. I just wanted to understand, when were these systems in Thracia created, and why was the system abandoned? This is a question for Jana, I think.
Yeah, I'm not sure I got the question quite right. I mean, you asked when the restoration took place.
So the question was, when were the systems created in Thracia, and why were they abandoned in the first place?
You mean historically when they were first?
Uh-huh.
As I think we all the assets, the architectural assets that are characterized as not exactly dates. The settlement of Avrilia dates back at least to the 19th century. When the systems were specifically built, I don't know if we have any historical data or any testimony of the locals. Grigoris, do you remember something? We're not sure when they were built.
We don't know. We don't really know. It's probably from 17th or 18th century, but we don't really know.
Yeah.
Oh, okay.
And they were abandoned because the home was gradually abandoned after the Second World War. So most of the population that lived there used to work for the quarries, for the Thiraner quarries, that were then after the 50s, 60s, when Santorini was starting developing as a tourist destination, and for many environmental reasons, the quarrying activities ceased. So people, as in many places of Greece, they moved to the big cities. They abandoned the peripheral regions. They moved to urban centers. And it is quite interesting that this population that they worked in the quarries there, they came in Africa and they moved, a large percentage of them moved to Lavrio, another industrial area of Attica, where there were mines also. So they were absorbed as a personnel in mining activity. Silver mining activities at that moment.
Okay. Thank you for your answer. Anybody else? No? You gave us a lot of information. We are very grateful for that. Okay. So I just wanted to ask one more thing, and that is, I saw that on the cistern in Thracia there was bushes in front of the places in which the water should come in. So is this a form of like purifying a filter, or and what kind of a plant is that?
Yes, you're totally right. I forgot to mention that. Yeah, it is a kind of local vegetation called apirilas, right, Grigori?
It's a sort of a bush.
It's a sort of a douche that is used to filter the water before inserting the system. And we have two systems that we restored. They were of public use and mostly for use. They were mostly used for irrigation purposes. But every house had its own private system, and when it rained, when it used to rain, they would prevent the first water that would come down the pathway to enter their system, because it would also bring all the debris, all the stones, etc. So they had more ways to filter the water that they would consume also. But this was of public use, using mostly this kind of vegetation to filter.
Okay, thank you. Okay, yes, it's interesting to understand that also the vegetation was one part of the whole water system management, and that it had a specific and important role within it. Okay, no questions? No? Thank you very much again for your presentation. And hopefully see you in autumn 2024 in EOS Island. Thank you so much for participating in our project this way.
Thank you very much, Maya, and the rest of the team.
Thank you, Maya. Thank you, everyone.
Okay, I'm gonna stop recording now. Thank you again.